Okay, so I want to pick up today where we left off yesterday, and I've gone ahead and put the addition and subtraction formulas up in the corner so that we have those for reference. Having your unit circle out would be really, really helpful. I want to finish up problem number 3. We were almost at the end of this problem yesterday when the bell rang, and then I talked like 30 more seconds. So I want to multiply these two values together, square root of 2 over 2 and square root of 3 over 2. What do I get when I multiply those two? Square root of square root of 6 over what? Over 4. Multiply top to top, bottom to bottom. We are allowed to multiply the pieces under the radical together. I'm going to bring my subtraction down, and then we're going to multiply these two fractions together. What is 1/2 times square root of 2 over 2? Square root of 2 over 4. Can I write that as a single fraction? Yes. What would that look like written as a single fraction? Yep. Square root of 6 minus square root of 2 all over 4. And that would be my exact solution, my exact value. I realize that's like way down there on the screen. I will try to make sure that the next ones don't end up so far down. For number 4, is 7 pi over 12 on my unit circle? No. So I need to think up some way. With sine, we decided to use subtraction, but I picked two values off my unit circle so that when I subtracted them, I got 15 degrees. I need to think up some way to take values that I know from my unit circle and either add them together or subtract them and end up with 7 pi over 12. Pi over 4 and pi over 3. So 3 pi over 12 plus 4 pi over 12. You guys agree that that would add to 7 pi over 12? So I'm going to rewrite it like that first. Cosine of 3 pi over 12 plus 4 pi over 12. And I can reduce 3 pi over 12. Pi over 4. Can I reduce 4 pi over 12? Pi over 3. So now I have this angle written as the sum of two angles that are on my unit circle. So now I'm going to go grab one of my formulas. Am I going to grab an addition or subtraction formula? Addition. Do I want a sine, a cosine, or a tangent formula? Cosine. Tell me what you notice about the cosine formulas, either one of them, compared to the sine formulas.
The cosine and sines are grouped together instead of being grouped by not that.
That's exactly correct. In our cosine, addition, or subtraction formulas, we have cosine, cosine, and then we have an operator, either a plus or a minus, and then sine, sine. For my sine, addition, and subtraction formulas, it's sine, cosine, operator, sine, cosine. So we're like mixing our functions together with the sines. With the cosines, it's both cosines and then both sines. All right, so I need cosine of pi over 4 times cosine of pi over 3. What operator do I want in between? Look at the formula. Cosine is weird. It groups my cosines at the front, it groups my sines at the back, but then it is the opposite operator. Sine, it stayed the same operation. But for cosine, it changes. So I have minus here, and then it's going to be sine of pi over 4, sine of pi over 3. All right, let's talk about exact values. Cosine of pi over 4. What is cosine of pi over 4? Square root of 2 over 2. What is cosine of pi over 3? 1/2. And I'm multiplying these two together, and so I would get what? Yep, square root of 2 over 4. I'm going to bring my operator down. I'm trying to avoid the word sine because we also have a trig function called sine, so I'm calling it an operator instead of plus or minus. Is that fair? That's why I keep saying operator instead of what's the sign in between them. What is sine of pi over 4 is square root of 2 over 2 times sine of pi over 3, square root of 3 over 2. So how does that simplify? Square root of 6 over 4. Can I write that as one fraction? Yes, square root of 2 minus square root of 6 all over 4. Managed to get that one a little higher on the screen. Somebody asked me in 4th period today, will it always be over 4? Well, if I'm multiplying two trig functions together and it's anything except for like 0 or pi over 2 or 3 pi over 2, yeah, it's going to end up over 4 because I'm taking something with a denominator of 2 and multiplying it by something else with a denominator of 2. So most of the time we're going to end up over 4. Not always, there's a couple exceptions, but not very many. You guys okay if I put up the next couple examples? All right. Hardest part of this section is memorizing our addition and subtraction formulas. Second hardest part is just figuring out what values from the unit circle I can use to either add or subtract to get this angle. So when I see 195, the very first thing my brain does is, oh, that's 180 plus 15. Why is that a problem? 15 is not one of the values on my unit circle. 180 is, 15 is not. So I've got to think up different ones. You said 225 minus 30? Is that the only way we can get to 125? Yeah, you could do 150 plus 45. There's lots of different ways that you can get to 195. So the way you would set up a problem and the way I would set up a problem might be different, but we're going to end up with the same final answer as long as you apply the formulas correctly. I'm going to go ahead and use that 225 minus 30 just because it was the first one that I heard. There's nothing wrong with the other one. So I'm going to write cosine of 225 degrees minus 30 degrees. How does a cosine addition or subtraction formula start? Cosine times cosine. Cosine of one angle times cosine of the other angle. So I have cosine of 225 times cosine of 30. Tell me about the operator between them. It's going to be a plus because it's going to be the opposite. I'm going to do that in purple instead of blue. And then how does a cosine formula end? It starts with cosine, cosine. Sine, sine. So sine of 225 times sine of 30. Then we pull out our unit circle and we get our exact values. 225 is in what quadrant? Third quadrant. So what do you know about the cosine values in the third quadrant? They are negative. So I've got negative root 2 over 2. Cosine of 30 degrees. Positive. Square root of 3 over 2. Here's the way I remember these. 30 degrees is not very far off the x-axis, right?
I think it's pi over 3 for some reason.
Yeah, well, 30 degrees and pi over 3, my brain does the same thing. This is why when I was in PreCal, I would sit there and I would do my hand before I would write the numbers down. 30 degrees is not very far. I'm further along the x-axis. Root 3 is bigger than 1/2. I multiply those two together, and I get what? Negative square root of 6 over 4. I'm going to bring my operator down. Pedro, I promise that this is more important, even though it might not be more exciting. You said 225 degrees is in the third quadrant, so tell me about the sine value. It is also negative. Yep, negative root 2 over 2. Sine of 30 degrees, that's my 1/2. Multiply those two together, and I get what? Negative square root of 2 over 4. Can I write this as a single fraction? Yes. Negative square root of 6 minus square root of 2 all over 4. I would like you guys to do number 6 on your own. I'm going to give us about 2.5 minutes. So let's look at just the 23 over 12. What are some different ways that you guys got to 23 pi over 12? You said what? 7 pi over 6 plus 3 pi over 4. Because what that would be is 14 pi over 12 plus 9 pi. Sorry, my brain all of a sudden not working. 9 pi over 12. That would get me to 23. Did anybody get to 23 pi over 12 a different way? Yes, ma'am.
Pi over 3 and 5 pi over 4.
You said 2 pi over 3 and 5 pi over 4? 2 pi over 3 plus 5 pi over 4, because that would be 8 pi over 12 plus 15 pi over 12. Absolutely. Did anybody do it a different way? 5 pi over 3 and pi over 4. Hold on, let me scoot this over, and it's being difficult now. All right, I'm going to need you to repeat that one more time for me. You said 5 pi over 3 plus pi over 4. Because that would be 20 pi over 12 plus 3 pi over 12. Absolutely. So there's lots of different ways that we can get to 23 pi over 12. I'm going to go with the first suggestion that we heard. All of these will get you to the same place. It does not matter as long as you get them to add up to 23 pi over 12, and they are values from your unit circle. So I'm going to rewrite this as sine of 14 pi over 12 plus 9 pi over 12, which would reduce to 7 pi over 6 plus 3 pi over 4. So far, so good? All right. Do the sine addition and subtraction formulas start with sine, sine, like cosine does? No, the sine ones look like what? Sine and then cosine. So it's going to be sine of my first angle, 7 pi over 6, times cosine of my second angle, 3 pi over 4. Tell me about the operator in between. Plus stays the same. And then what's it look like at the end? Sine, cosine. Sine of what? 3 pi over 4, whoever you left out the first time. And then cosine of 7 pi over 6. So far, so good? What is sine of 7 pi over 6? Negative 1/2. We're going to multiply that to the cosine of 3 pi over 4. What's cosine of 3 pi over 4? Negative square root of 2 over 2. So I multiply those together and get what? Square root of 2 over 4. I'm going to bring down my operator here. Sine of 3 pi over 4. Square root of 2 over 2 times the cosine of 7 pi over 6 square root of 3 over 2. Positive or negative? Negative. It's in the it's in the third quadrant, so it's going to be negative. So I multiply those two together. I get negative square root of 6 over 4. Combine those together into a single fraction. I get radical 2 minus radical 6 all over 4. So far, so good? There is one of these formulas that we have not used yet, or one type of formula, I should say. Which one have we not touched at all? Tangent. Tangent's a hot mess. That's probably the hardest one to memorize of the different ones, is the two tangents. If you want to know why the tangent formula looks that messed up and where it came from, if you look in your book in section 7.3, they go through and show you how we arrive at this particular formula. Huh? Yeah, it's basically sine over cosine and then simplified. I want to give you guys about another 2.5 minutes, see what you can do with this one. And then we'll come back together and do it together. While you guys are doing that, this is not your quiz from yesterday. I will pass that back later. This is the very first quiz from the semester, way back in chapter 6. But everybody has taken them now, so I'm returning them to you guys to keep. So this is like forever old. These are forever old. You guys have seen these before. They are yours to keep now. Okay. How did we get to pi over 12? Pi over 3 minus pi over 4. So 4 pi over 12 minus 3 pi over 12, which is the same thing as pi over 3 minus pi over 4. So far, so good? Is that the only way to get to pi over 12? No. That's one way to get to pi over 12, and it works. So now we're going to move to our tangent formula. I need a fraction. In the numerator, I'm going to have tangent of my first angle. I'm going to have tangent of my second angle. Oops. Tell me about the operator between them. Minus. I'm going to keep the sign here. The denominator always starts with a 1. Tell me about the operator there. It's going to be the opposite. And then it's tangent of my first angle times tangent of my second angle. So what is tangent of pi over 3? Yes, ma'am.
Why is the pi over 4 not negative?
So we're applying this formula right here. The pi over 4 is not negative. I'm subtracting these two angles. It's not a negative pi over 4. I'm not going clockwise around my unit circle. Does that make sense? That's why. I know that tangent is sine over cosine. So I want to know tangent of pi over 3. What is tangent of pi over 3? What is sine over cosine? Square root of 3. So I have radical 3 minus, what is tangent of pi over 4? 1. Over, and I know this is 1 plus, and then I have radical 3 times 1. So far, so good? Okay. So in my numerator, I can't really do anything there. Radical 3 minus 1 over 1 plus radical 3. Am I allowed to leave a denominator like that? Have to rationalize. How do you rationalize a denominator like that? Multiplied by the, starts with a C and it's a fairly long word. Conjugate. We're going to multiply by the conjugate. What does the conjugate look like? Yes, 1 minus square root of 3. Same thing, top and bottom. This is going to get the radical out of my denominator. So I'm going to double distribute here. Radical 3 times 1, well, that's radical 3. What is radical 3 times negative radical 3? Negative 3, so minus 3. Then I distribute negative 1 to 1, so minus 1. Negative times a negative? Positive, so plus radical 3 over, and now I have to double distribute down here as well. I do 1 times 1, which is 1. 1 times negative radical 3, so minus radical 3. Radical 3 times 1, so plus radical 3. Radical 3 times negative radical 3, so minus 3. Let's clean this up. Is there anything that I can combine in the numerator? Yep. Negative 3 and negative 1 gives me what? Negative 4. So I'm going to bring this here. So I have negative 4. And then I have radical 3 plus radical 3. Plus 2 radical 3. Works the same way as if I had x plus x. I have 2 of the exact same things. Can I clean up anything in the denominator? Yep. I have 1 minus 3, and my radical 3's cancel each other out. Remember, the whole goal of multiplying by the conjugate was to make those radicals cancel. What is 1 minus 3? Negative 2. I can take out a 2. I can do more than just take out a 2. I can take out a negative 2. So I'm going to factor a negative 2 out of my numerator. What would that leave me with up top? 2 minus radical 3 over negative 2. So my negative 2's cancel. And my final answer would be 2 minus radical 3. Woo! Do you guys have any questions for me on that? I want to look at one more type of problem. We're going to kind of switch gears. We're going to look at this in reverse. I'd like to look at 2 more problems with you today. And then we're going to shut it down so that I can pass back your quizzes from yesterday so you guys can see how you did on those. Okay? We're still talking about the addition and subtraction formulas, but we're going to work in reverse. I want to write this as a trigonometric function of just one angle. What do you notice this example starts with? Cosine, cosine. So am I using a cosine formula or a sine formula? Cosine. So I know it's going to be cosine. I know I've got 78 and 18. What operator do I put in between them? Minus. Because cosine always has the opposite sign, or the opposite operator. So what's 78 minus 18? 60. Yep, it says then evaluate if possible. Cosine of 60 degrees is what? What'd you say? 1 over 2. So far, so good? Let's look at one more example like this, and then, like I said, we'll shut it down after that. How did you know, again, that this was a cosine formula? Because it starts with cosine, cosine, right? Cosine, cosine is a cosine formula. Last example for today. Is this a cosine, a sine, or a tangent formula? Sine. It's sine times cosine, so we have a sine formula. I know my angles are 140 degrees and 50 degrees. What operator should I put between them? Plus. Because with our sine function, the operator stays the same. So this is going to be sine of what? 190. Can we evaluate sine of 190? Can I do it if I redo like an addition or subtraction? Can I get to 190? How could I do that? Tell me how to get to 190. Using only things that are on my unit circle. 135 and 45. That's 180. Yeah, I don't think it's possible. In fact, if you can find a way, to get to 190 using only unit circle angles, I will give you bonus points because I have not been able to figure out a way to do it. Yes, sir.
You used 3.
Huh?
You used 3.
Can you use 3?
Yeah, like 3 angles.
If you want to get real messy, you could. But yeah, if you can figure out a way to do it to find an exact value, I will give bonus points. I haven't been able to figure out a way to do it with just 2 angles. If you can find a way to do it with 3 angles and find an exact value, I will give bonus points. All right, we are done with notes for today. I'm going to pass back your quizzes.